We are reading the Experience Over Time major section, which leads us to the core topic of how our understanding of the world evolves. So far, we read how we're going to use collective knowledge, so science, philosophy, and our intuitive experience to make sense of how we understand the world and our freedom within it. Most recently, we discussed the Experience in the Moment major section, which discussed topics like predictive processing, how the brain models reality to regulate itself, how this results in the intuitive experience we have. So the gap remains. We know how the brain constructs meaning in the moment, but not how it constructs it differently over time. So let's get right to it. In the previous section, we examined how our experience of meaning is not passively received, but actively constructed, shaped through predictive models continuously refined by memory, mood, attention, and embodied engagement. Crucially, we saw that these models are not fixed. Over time, our experience of the world changes. What then accounts for these shifts in experience? Much earlier, we acknowledged that the material world, including our physiology, is governed by physical processes. The cells of our body, the chemicals that modulate brain function, the sensory systems that interface with the environment, all operate according to physical laws. Yet, while the world itself may appear to change, we've seen that meaning does not arise solely from external conditions. Our experience is constantly modulated by our internal state, our physiological readiness, emotional tone, background expectations, and learned patterns of attention. At any given moment, experience is in some sense predisposed by a dynamic configuration of biological, developmental, and situational influences, determining what stands out, what feels possible, and what demands our focus. In this section, we shift from examining the mechanisms that support experience to exploring the forces that shape how those mechanisms change. By clarifying the specific notion of predisposition, not as a fixed trait, but as a living trajectory, we can begin to trace how experience is always already conditioned. What affects this predisposition? Which aspects of it remain stable across time, and which fluctuate, either gradually through development or rapidly from moment to moment? So let's consider what we mean by this notion of predisposition. We already have an intuitive sense of what it means to speak of a disposition, a set of tendencies that influence how we feel, perceive, and act. Often this idea is associated with temperament, personality, or inherited traits, things that seem relatively stable across time. In this section, we refine that intuition, aiming to hone in on a notion of predisposition that allows us to make sense of our dynamic experience. This shift in framing invites a broader view, to consider experience not as something passively received or neutrally constructed, but as something continuously conditioned by biology, memory, mood, development, and context. What we notice, what seems possible, what feels meaningful or real, each of these is shaped by a background configuration that orients us before we even begin to reflect. Here, we can clarify what affects this configuration. We begin by exploring the most familiar contributors, genes, temperament, and early learning, and gradually work toward the dynamic systems that guide understanding in real time. Our goal is not to draw strict lines between what can or cannot be changed, but to develop a more precise perspective of what contributes to experience, how those contributions evolve, and how they give rise to the in-the-moment sense of what is true, relevant, or possible. All right, so let's start with one of the most fundamental perspectives that we could take: genetics, nature, and nurture. When we consider why people differ in their thoughts, feelings, or actions, we often attribute these variations to temperament or personality. Some people are naturally cautious, others adventurous. Some feel emotions intensely, others take life in stride. These intuitions reflect a reality. Each of us possesses inherent tendencies that influence how we encounter the world. But what underlies these tendencies, and how do they interact with experience over time? A significant part of this answer lies in our genetics. Each cell in the body contains DNA, long molecules made up of chemical sequences called genes. In simple terms, a gene is a segment of DNA that tells the cell how to build a specific protein. These proteins carry out essential tasks. They form the structure of cells, drive chemical reactions, and help regulate systems like the nervous system. In this way, genes influence everything from how the brain develops to how we respond to internal and external stimuli. Each person's genome is inherited from their parents, half from their mother, half from their father. This inheritance explains observable similarities between family members, from physical appearance to certain behavioral tendencies. But it's important to understand that most traits, especially psychological ones, aren't dictated by a single gene. Instead, they result from the combined influence of many genes, each contributing a small effect. Traits like intelligence, mood, or risk tolerance are shaped by the additive effects of numerous genetic variants, each nudging our development in subtle ways. Crucially, the human genome is overwhelmingly shared. About 99.9% of our DNA is identical to that of every other human being, giving rise to the universal features of human experience: our core emotions, the basic structure of perception, our reactions to danger, and our drive for social connection. These shared systems are what make human experience intelligible across cultures and individuals. Yet within this shared architecture, genetic variation still plays an important role. Small differences in DNA can influence a wide range of traits, from physical features like height and metabolism to less visible factors such as hormone regulation, immune function, and brain chemistry. These biological differences, in turn, shape how people respond to the world around them. For example, genetic variability can affect how sensitive someone is to stress, how quickly they recover from threat, or how intensely they experience reward. These traits contribute to individual differences in attention, emotional regulation, and temperament, core ingredients in how meaning is registered and interpreted differently from person to person. Moreover, our genetic mechanisms are not executed in isolation from the world. Their effects unfold through continuous interaction with the environment. This dynamic relationship is governed in part by epigenetic mechanisms, biochemical processes that influence whether a gene is expressed or silenced based on environmental conditions. Epigenetics does not change the DNA sequence itself, but it does momentarily modify how accessible certain genes are, effectively turning them on or off. A useful metaphor is to think of our genome as a piano. The keys represent our genes, and life experiences determine which keys are played, in what sequence, and with what intensity, producing the unique melody of an individual life. These changes can be triggered by a wide range of immediate physiological and sensory inputs, such as stress hormones, neurotransmitter levels, body temperature, immune activity, sensory stimulation, oxygen availability, and metabolic resource availability. Even subtle shifts in light exposure or social context can influence how genes are expressed in the moment. In this way, experience becomes biologically encoded, not by altering the genetic sequence, but by influencing how that sequence is expressed. Some gene expression is modulated in real time, influenced by acute shifts in the body. Others reflect more lasting adaptations, emerging from prolonged environmental influences like early caregiving, chronic stress, or sustained learning. Both forms of modulation show that gene expression is not fixed. It is constantly shaped by the interplay between biology and context. Both forms of modulation show that gene expression is not fixed. It is constantly shaped by the interplay between biology and environment. Thus, our physical environment plays a crucial role in shaping cognitive function and meaning perception. Nutrition, sleep, and sensory stimulation directly impact brain development and maintenance. For instance, malnutrition in early childhood has been linked to cognitive impairments, whereas proper nutrition supports optimal neural function. Similarly, chronic stress or exposure to environmental toxins can negatively impact how individuals process information and engage with meaning. In this light, genetics is not destiny. Our genome provides a scaffold, one that defines both constraints and affordances. While our genetic code sets limits on developmental possibilities, it also permits remarkable variability in outcome. This variability, driven by gene-environment interaction, explains how individuals with identical genomes, such as identical twins, can nonetheless develop different cognitive, emotional, and behavioral tendencies depending on their unique life histories. Rather than treat nature and nurture as competing explanations, we can understand predisposition as the product of their interaction. The genome provides a range of possible configurations. Experience and environment determines which ones are realized. In every moment, our experience reflects the ongoing expression of this interaction. This gives us an initial perspective on our notion of predisposition, not a fixed trait, but an evolving orientation shaped by the interaction between biology and environment. In the next section, we'll draw a more explicit contrast between this dynamic view and the more familiar notion of disposition, those traits we often regard as static or unchanging. By doing so, we'll clarify how moment-to-moment experience is both constrained by our nature and open to transformation. Okay, so differentiating predisposition from disposition. So far, we have discussed the foundation of how our moment-to-moment experience is shaped by the ongoing interplay between biology and lived experience. The outcome of this process is an evolving configuration of internal factors that shape our experience and ultimately how meaning appears to us in any given moment. We introduce predisposition as a term to describe these contributors to experience, distinct from the more commonly understood concept of disposition. In everyday language, disposition often refers to relatively stable psychological or behavioral tendencies. We might say someone is patient, anxious, open, or introverted, traits that describe how they tend to respond across situations. These intuitive descriptions are meaningful because they track real, observable consistencies in behavior and emotion over time. And many of these tendencies reflect enduring neurobiological patterns shaped by both genetics and environmental interaction. While we have growing insight into the neural and genetic foundations of behavior, it's important to acknowledge that much remains unknown. The complexity of gene expression, developmental variability, and brain-environment interaction makes it difficult to isolate exactly how innate biology shapes moment-to-moment experience. Nevertheless, research in behavioral genetics and personality psychology offers valuable clues, allowing us to identify stable patterns that often persist across time and context. For example, temperament, our baseline tendency toward alertness, sociability, sensitivity, or irritability, is often established early in life and shows remarkable continuity over the lifespan. Twin and adoption studies indicate that many aspects of temperament are moderately to highly heritable, reflecting stable patterns in neural reactivity and emotional regulation. Yet, temperament is also shaped by early environment. Factors like caregiving quality, attachment security, and early stress can influence how these tendencies manifest and develop. While the majority of people retain their early temperamental profiles into adulthood, these traits are not entirely immutable. Research suggests that a significant minority of individuals, roughly 20 to 25%, undergo meaningful changes over time. Thus, temperament represents a stable but potentially modifiable disposition, deeply rooted in biology, but open to environmental influence and developmental change. In addition to temperament, certain cognitive capacities, such as general cognitive ability and specific executive functions like working memory, inhibition, and cognitive flexibility. Large-scale twin and family studies consistently demonstrate that general cognitive ability and common executive functions are strongly influenced by genetic factors, particularly in adulthood when shared environmental effects tend to wane. These inherited cognitive traits shape not only how we process and retain information, but also how flexibly we adapt, regulate emotion, and shift between perspectives, capacities that critically affect how meaning is constructed in real time. Conversely, biological affective systems, such as those governing fear, attachment, exploration, or play, are conserved across all humans. These core systems, grounded in subcortical structures like the amygdala, hypothalamus, and brainstem, are part of what makes meaningful experience recognizable and communicable. They are shared features of the human condition, shaped by evolution and embedded in our neurobiology. The feeling of threat, the drive to seek connection, the impulse to explore, all of these have biological roots that help explain commonalities across individuals and cultures. We can think of these stable elements, temperament, cognition, and universal human biology, as contributing to the dispositional backbone of human experience. They do not determine the specific content of our thoughts, feelings, or beliefs, but they strongly influence how we tend to interpret and respond to the world. In this sense, disposition provides a kind of personal baseline, a relatively stable orientation toward experience that varies from one person to the next, but within the bounds of a shared human template. However, the notion of predisposition we are developing refers to something more immediate and dynamic. It does not describe our enduring traits across time, but our moment-to-moment orientation toward experience, shaped by the interaction of stable traits, internal states, environmental cues, and mental framing. Where disposition reflects long-term tendencies, predisposition reflects something like a current state. A person with an anxious disposition may not always feel anxious. Their tendency might influence how easily a situation feels threatening, but whether anxiety actually arises depends on a host of other factors: sleep, recent thoughts, the presence of others, or even subtle changes in posture or tone. By clarifying the distinction between disposition and predisposition, we begin to see experience not simply as the unfolding of fixed traits, but as the product of a dynamic and ever-shifting orientation. This framing allows us to ask questions that more static views cannot. What is shaping our experience right now? Which factors are stable and which are open to influence? And most crucially, can we ever become aware of these influences in a way that allows us to shape them deliberately? All right, so let's consider how understanding relates to what we've just discussed. If our experience is always shaped by a shifting background of tendencies, by a predisposition, then it becomes essential to ask, which aspects of that predisposition are actually accessible to us within experience? Which can we learn from, and which might we be able to shape? Among all the many contributors to our moment-to-moment orientation, one stands out as especially relevant: our understanding. In everyday language, we often speak of understanding as something we have, lack, seek, or gain. This intuitive framing reflects something real. Unlike aspects of our predispositions such as genetics or metabolism, which influence our experience without necessarily entering conscious awareness, understanding is something we largely recognize intuitively. We notice when it grows, falters, or fails to meet a situation. We can reflect on it, identify it, and attempt to change it. For this reason, we treat understanding as a privileged aspect of predisposition, not because it is independent of other influences, but because it is a dimension of our orientation that we can directly, consciously engage with. Importantly, we do not treat understanding as an abstract capacity or philosophical category. In the context of this framework, understanding refers to a real-time configuration of the brain, specifically the structures and patterns that integrate memory, attention, and conceptual knowledge to guide ongoing interpretation. This structure plays a critical role in how we recognize, anticipate, and assign meaning to experience. While many neural processes operate beneath awareness, understanding is one that we often encounter reflectively, especially when it is disrupted, challenged, or consciously revised. We can think of understanding as the aspect of our predictive orientation most closely tied to knowledge, memory, and conceptually structured expectations. It is shaped by what we've previously learned and by the interpretive habits we've developed, allowing us to navigate familiar experiences fluently while struggling with those that exceed or violate our expectations. When we experience meaning, we are not just responding to sensory input. We are interpreting that input through the lens of prior experience. This interpretive frame is largely constructed by our current state of understanding. Still, understanding is not identical with our overall predictive model of the world. Many aspects of that model, such as instinct, emotional reactivity, or motor prediction, operate independently of what we would call understanding. These embodied non-conceptual elements are equally essential to how meaning unfolds in experience, but we can think about understanding as referring to those elements of the model that represent what we know, what we expect, and what we are capable of interpreting, especially at the conceptual and relational level. It is this interpretive layer that gives meaning its intelligibility. This brings us back to the experience of meaning itself. As we've seen throughout this document, meaning does not arise from the external world alone. It emerges through the brain's active modeling of the world in relation to memory, emotion, and bodily engagement. Understanding, then, can be seen as the component of our real-time predisposition that most directly structures how meaning becomes available to thought. It's not that understanding causes meaning, but that it shapes what feels meaningful in light of what we already grasp, expect, or assume. Even our ability to notice and question our emotional or bodily responses depends, in part, on how those responses are framed by our understanding. That is why we can consider understanding as a crucial aspect of predisposition. It is not the entirety of how we orient to the world, but it is the aspect most available to reflection. something we can notice, examine, and sometimes consciously shift. It offers a relatively accessible and flexible point of entry into the otherwise automatic flow of experience. Through it, we can bring assumptions to light, question what feels self-evident, and begin to reshape the interpretive habits that quietly guide how meaning appears. In the next section, we explore how this structure of understanding forms, stabilizes, and adapts through mechanisms such as memory, learning, habit, affect, and social reinforcement. In doing so, we begin to see how the shaping of experience is never static, but constantly unfolding, and how our understanding of the world is both a result of that process and potentially a lever for its transformation. Up until this point, we framed understanding as a central feature of predisposition, something that not only reflects our cognitive and emotional state, but also shapes how we interpret the world. We've seen that understanding is both biologically grounded and subjectively accessible. It arises from complex neural activity, yet can be felt, examined, and even reoriented through reflection. Because it is both embodied and reflectively available, understanding holds a unique position among the forces that shape experience. We may not always be able to control the full scope of our predisposition, but we can begin to reflect on how understanding filters our attention, influences what we expect, and determines what we take to be meaningful. And if we can reflect on it, we can begin to learn from it, work with it, and potentially, over time, transform it. Yet while this framing gives us a conceptual foundation, we've only begun to glimpse how understanding might unfold in real time. What actually happens, biologically and cognitively, as our experience takes shape in the present? What mechanisms allow past learning, current moods, and shifting attention to dynamically configure what we perceive, anticipate, and feel? In this section, we aim to connect those foundational insights with the neurocognitive dynamics introduced earlier, bringing together insights from genetics, neuromodulation, memory, and attention to explore how experience is continuously shaped. We begin with the brain's capacity for change, its remarkable ability to adapt in response to experience. To understand how our grasp of the world can change, sometimes subtly, sometimes profoundly, we must examine the physical capacity that makes this change possible. The brain is not a static organ. It is continually adapting, reshaping itself in response to experience. Neuroplasticity, the brain's inherent ability to reorganize itself, provides the physiological foundation for learning, memory, and the ongoing evolution of our understanding. This plasticity allows us to not only encode new experience, but also to revise long-standing assumptions, habits, and patterns of thought. It is this capacity that grounds our ability to reflect, to grow, and to deliberately shape how we interpret and engage with the world. As we have seen, the brain operates through vast networks of neurons that communicate via electrical impulses and chemical messengers. These interactions occur at synapses between neurons, where neurotransmitters facilitate the transfer of information. Critically, these synaptic connections are not fixed, they are malleable. Repeated activity can strengthen connections, while disuse can weaken or eliminate them. This plasticity allows neural circuits to adjust based on the patterns of experience, shaping how perception, attention, emotion, and understanding evolve over time. Several distinct processes contribute to this adaptability. Synaptogenesis creates new connections between neurons, expanding the brain's capacity to process and integrate information. Synaptic pruning, by contrast, eliminates underused or inefficient pathways, sharpening cognitive efficiency by allowing the most relevant connections to remain. Long-term potentiation strengthens synapses through repeated co-activation, laying the foundation for learning and memory. In some brain regions, neurogenesis, the birth of new neurons, continues into adulthood, supporting cognitive flexibility and adaptation. These processes ensure that neuroplasticity is not merely additive, but also selective. Just as new pathways form, old ones are narrowed, forgotten, or erased. One can think of neural activity like paths through a forest. The more often a path is walked, the clearer and easier it becomes to follow. Conversely, unused paths become overgrown and eventually disappear. This ongoing pruning and reinforcement process explains how frequently used ways of thinking and perceiving become more accessible, while those that are not fade over time. Sleep plays a vital role in this reorganization. During deep sleep, Patterns of activation from waking experience are replayed and consolidated, reinforcing relevant connections. In REM sleep, associative reorganization occurs, allowing the brain to generate novel links between seemingly unrelated ideas or memories. Sleep thus functions not just as rest, but as active reconfiguration, a mechanism through which experience is integrated, forgotten, or reinterpreted. Plasticity is most pronounced in early development, when the brain is rapidly building and pruning connections in response to sensory, emotional, and social inputs. During this period, connections form quickly and easily, shaping the foundational frameworks through which we interpret and respond to the world. These early experiences establish durable patterns of understanding that we can think of as aspects of disposition, stable orientations that continue to influence what we come to expect, what feels salient or safe, and how we relate to others over time. Because plasticity declines with age, these initial frameworks often persist, continuing to shape experience long after their formation. Yet these structures are not final. The brain remains plastic throughout life, particularly in response to novelty, attention, and emotionally meaningful experience. In adulthood, neuroplasticity tends to depend more on context and deliberate engagement. While new learning and personal transformation remain possible, they often require sustained attention, repetition, and a degree of emotional relevance. Long reinforced pathways are more easily activated, while those that conflict with prior models may take significant effort to revise. This helps explain why practices like reflection, emotional insight, and repeated exposure are often necessary to shift how we understand and engage with the world. In this light, neuroplasticity offers a concrete physiological grounding for understanding. Each moment of experience subtly reshapes the functional architecture of the brain, modifying how we perceive, what we expect, and how we respond. It is through this continual reorganization that understanding evolves, habit solidifies, and meaning becomes either reinforced or reimagined. In the previous subsection, we explored the brain's capacity to change, how neuroplasticity enables new learning, the revision of old patterns, and the ongoing reconfiguration of understanding. But why do some experiences leave lasting impressions while others fade away? Intuitively, we know that not all experiences are encoded equally. As we scan a room, listen to a conversation, or navigate daily life, only certain elements capture our attention, enter memory, and reshape our models of the world. We've already seen that experience is actively shaped by our emotional state. Mood and emotion influence which aspects of experience feel significant, both in the moment and as we think back about them. So we might ask, how do these emotional dynamics also shape how we come to understand the world in enduring ways? To explore this, we can think back to our discussion of the brain's neuromodulatory systems and how they connect with neuroplasticity. Neuromodulators are chemical messengers like dopamine, norepinephrine, serotonin, and acetylcholine that broadly regulate neural excitability. Unlike the rapid, targeted signals sent across individual synapses, neuromodulators diffuse across larger regions of the brain, tuning the sensitivity of neuronal populations and shifting the overall state of brain networks. This tuning power is significant for learning. By regulating the excitability of neurons, neuromodulators influence which neural pathways are most likely to activate, and therefore which are most susceptible to plastic change. In this way, neuromodulation shapes the conditions under which synaptic strengthening and weakening occurs. When a brain region is placed in a high modulation state, such as during emotional arousal, novelty, or focused attention, its neural circuits become more responsive to input and more likely to undergo the kinds of structural changes that support learning. This means that mood and emotion, via neuromodulatory tone, don't just alter perception in the moment, they directly influence which experiences are consolidated into long-term patterns of understanding. When attention is drawn to an emotionally significant event, whether it's a moment of danger, reward, novelty, or uncertainty, neuromodulatory systems respond by altering the brain's plasticity landscape. Regions like the amygdala evaluate the emotional salience of the experience and signal for the release of neuromodulators. These neuromodulators then diffuse broadly across neural circuits, modulating the sensitivity of neurons involved in processing the attended stimuli. In doing so, they bias the strength and timing of synaptic changes. Pathways that are coactive during these high salience moments are more likely to undergo long-term potentiation, the physiological basis of learning. As a result, the attended emotionally charged experience is more robustly encoded into memory and more readily integrated into the brain's predictive models. This convergence of attention, affect, and neuromodulation ensures that the brain doesn't simply record what happens, but selectively strengthens patterns that are most likely to matter for future actions and interpretation. Each neuromodulator plays a distinct role in this process, contributing differently to how information is selected, processed, and encoded. Dopamine acts as a learning signal that reinforces neural pathways associated with positive surprise. When the outcome of a situation is better than expected, or when a new piece of information meaningfully reduces uncertainty, dopamine is released in proportion to the unexpectedness of that reward or insight. This surge retroactively enhances the perceived significance of the event, strengthening the neural pathways that contributed to the unexpected outcome and making those patterns more likely to be repeated or recalled in similar future situations. Norepinephrine, by contrast, is more closely tied to the detection of novelty, uncertainty, or potential threat, regardless of valence. Its effect is to heighten vigilance and sharpen attention, flagging events as potentially significant. This heightened sensitivity promotes the detection of important environmental changes and facilitates learning under uncertain or high-stakes conditions, where quick updating of internal models is critical. Acetylcholine plays a central role in directing attention and supporting the encoding of new information. Its release is closely linked to states of focused engagement, particularly when we are deliberately learning something or attending to a stimulus that has been determined as salient. By enhancing signal-to-noise ratios in relevant neural circuits, acetylcholine sharpens the brain's capacity to select and stabilize inputs for memory formation. It facilitates the consolidation of meaningful experiences by helping the brain assign precision to what matters most in a given context, effectively tuning the weight of sensory information relative to existing expectations. Serotonin plays a more diffuse regulatory role in shaping the emotional landscape within which learning unfolds. Rather than amplifying specific moments, it helps stabilize mood and buffer against excessive emotional reactivity, particularly in the face of uncertainty or negative outcomes. Elevated serotonin levels are associated with increased behavioral flexibility, promoting exploratory responses rather than rigid or habitual ones. In this way, serotonin influences whether we respond to challenging situations with openness and adaptability or with withdrawal and perseveration. Ultimately, neuromodulators influence not only what we learn, but also how deeply and selectively we learn it, shaping the trajectory of our understanding over time. We can think of their effect as a kind of affective tagging, an internal mechanism that marks certain experiences as relevant based on their emotional or motivational impact. These tags signal to the brain that certain moments carry heightened relevance, whether because they resolve uncertainty, offer reward, or signal threat, and should therefore be encoded with greater weight. A surprising or pleasant event, for instance, is more likely to be retained if accompanied by elevated dopamine and norepinephrine, reinforcing the neural pathways that led to that experience and sharpening future expectations around similar contexts. But this tagging mechanism doesn't always facilitate learning. In some cases, neuromodulatory responses inhibit integration. Highly stressful or aversive experiences, especially those perceived as overwhelming or unresolved, can trigger a surge of cortisol and norepinephrine that disrupts rather than supports plasticity. In such moments, attention may narrow too sharply, suppressing contextual awareness and impairing the formation of coherent memory traces. This helps explain why certain emotionally charged events are only partially remembered, fragmented, or avoided altogether in reflection. Rather than being assimilated into a flexible model of the world, these experiences may remain compartmentalized. Importantly, this process is not unidirectional. Just as neuromodulators shape our emotional experience, sustained emotional states, what we call mood, also influence the ongoing release of neuromodulators. A prolonged state of anxiety, for example, can bias the release of norepinephrine and cortisol, maintaining heightened vigilance and sensitivity to threat. Similarly, positive moods are often accompanied by a more consistent dopaminergic tone, reinforcing motivational engagement and openness to new information. These background emotional tones effectively shape the chemical environment of the brain, modulating the thresholds for learning and influencing which types of experience are more likely to be noticed, valued, and consolidated. When neuromodulatory responses recur, their effects can compound. Emotionally charged experiences, whether rewarding or distressing, reshape neural architecture in ways that influence how future events are perceived, which in turn shapes subsequent emotional responses and attentional biases. Over time, this recursive cycle can yield durable, adaptive patterns of understanding, or in the case of trauma or chronic stress, rigid and self-reinforcing models that are difficult to revise. In this way, neuromodulatory dynamics help determine not only what is marked as meaningful, but which interpretations become habitual and which expectations become entrenched. In sum, affective and neuromodulatory dynamics shape how the brain changes over time, not just in isolated events, but across developmental arcs. They determine which neural connections persist, which patterns are repeated, and how the architecture of understanding itself is gradually constructed. Through this lens, mood and emotion are not secondary to learning, they are fundamental to how the mind becomes what it is. If affectively significant experiences indeed drive lasting neural change, how then do they accumulate, transform, and solidify into the more enduring structures of our understanding? What are the processes by which these dynamic learning events give rise to the stable yet adaptable framework through which we perceive and navigate our world? Certain brain regions are involved in translating experiences into more enduring forms, while neuroplasticity, as a fundamental capacity for change, affects all regions of the brain. Certain areas become particularly pivotal when we consider the manifestation of our understanding through processes like memory formation, pattern recognition, and habitual interpretation. The hippocampus, for instance, which we previously noted for its role in organizing experiences as they happen, appears central to the initial formation of new episodic memories, those detailed, context-rich recollections of specific personal events. Studies involving individuals with hippocampal damage, for example, consistently show profound difficulties in forming new long-term memories for events and facts, even while other cognitive abilities might remain intact. Furthermore, neuroimaging techniques allow us to observe the hippocampus becoming highly active when individuals are successfully encoding new experiences or retrieving recent ones. This convergence of evidence points to its specialized function in the initial, rapid binding of the diverse sensory, emotional, and cognitive elements of an experience into a coherent initial memory trace. This initial binding then serves as a foundational step in creating a memory that can later be accessed and contribute to the recognition of broader patterns. However, for understanding to become more generalized and stable, these initially hippocampus-dependent memories often undergo further processing. Over time, and often facilitated during periods like sleep, the essential patterns and knowledge gleaned from individual experiences are gradually reorganized, abstracted, and integrated into the vast networks of the neocortex, particularly its association areas. The neocortex thus serves as the brain's primary long-term framework for generalized knowledge, conceptual understanding, and the complex patterns distilled from countless experiences. Then, the prefrontal cortex plays a crucial role in actively working with these stored patterns, allowing us to hold patterns in mind and compare them with new information. It facilitates the strategic retrieval of relevant memories and enables us to use these recognized patterns for reasoning and generating top-down predictions about the world. Through such interplay, stored patterns are actively applied and refined, contributing to our conscious experience of understanding. As these memory traces are formed, consolidated, and repeatedly activated, our ability to recognize patterns emerges. When current sensory input, or even a particular line of thought, sufficiently matches a well-established pattern represented by these neocortical networks, the specific neural ensemble corresponding to that pattern is activated. So, when we think about memory, it's crucial to understand that it is not like a repository of obviously distinguishable units, but rather as a complex, dynamic organization of synaptic connections. The storage of a memory or a pattern in the neocortex refers to the strengthening, weakening, and configuration of these connections in such a way that specific networks activate in a particular manner when cued. When we retrieve a memory or recognize a familiar pattern, specific ensembles of neurons across the neocortex become active in a coordinated fashion, reflecting the learned associations and strengthened pathways that constitute that particular piece of knowledge or understanding. This activation is the experienced memory or the recognized meaning in that moment. It is this neural reinstantiation of a learned pattern that then often triggers a distinct cognitive and affective experience, a feeling of familiarity. This feeling arises in part because the brain is essentially signaling, I've encountered something like this before, this pattern is known. As we alluded to when discussing the felt certainty of confirmed predictions, this familiarity can be understood as the subjective counterpart to the brain successfully matching incoming data to a learned model, an experience often accompanied by the neuromodulatory feedback, like stable or increased dopamine, that reinforces the validity of our internal models and contributes to the cyclical process of learning and understanding we touched upon in the previous subsections. Recognizing a familiar pattern is, in essence, a successful prediction based on past learning, and this recognition, in turn, allows us to form expectations about what might happen next or how to interpret an ambiguous situation. The strengthening and refinement of these patterns are powerfully driven by the same neuromodulatory mechanisms of reinforcement we explored earlier. When recognizing a pattern leads to a successful prediction, or when a particular interpretation or behavior is followed by a positive outcome, neuromodulators like dopamine signal this success, reinforcing the neural pathways that represent that pattern. This brings us to consider the well-established process of conditioning. Through classical conditioning, neutral cues, when repeatedly paired with significant events, become learned signals, predictive patterns that shape our expectations. Through operant conditioning, actions followed by reinforcement become ingrained patterns of behavior and thought. In both scenarios, neuromodulatory feedback is crucial for stamping in these associations, making certain patterns more likely to be recognized and utilized. With sufficient repetition and reinforcement, these patterns of thought, interpretation, and response can transition from requiring effortful, conscious processing to becoming largely automatic. This represents a highly efficient mode of learning, where the brain optimizes its resources by proceduralizing frequently used cognitive operations. It converts a sequence of actions or mental steps that initially required conscious attention and control into a more streamlined, almost reflexive process that can be executed with minimal conscious oversight, much like learning to ride a bike or to type on a keyboard. We thus can think about our automatic experience of meaning as the manifestation of cognitive habits, automatic ways of understanding situations or categorizing information, all based on these deeply learned patterns. When a familiar stimulus is encountered, it can trigger a well-established cascade of neural activity, leading to an immediate feeling of familiarity and certainty. This shift toward automatic processing often involves an increased role for structures like the basal ganglia, known for their involvement in executing learned routines, thereby freeing up the prefrontal cortex for novel challenges. Because, as we've discussed, learning involves the physical alteration of neural connections, and because these connections are subject to ongoing neuroplastic processes, it follows that memory is not a static recording, but an active, reconstructive process. The neural pathways forming a memory trace are not fixed. They are subject to the same processes of synaptic strengthening, weakening, and reorganization that characterizes all learning. As these connections in our brain change, so too can the experience that is reconstructed during recall. Indeed, retrieving a memory can make its underlying trace temporarily open to change, allowing it to be updated or subtly altered before it is reconsolidated. Over time, the natural pruning of synaptic connections can lead to memories becoming more generalized or schematic, This means that our understanding of past events, and therefore the patterns and lessons we derive from them, can evolve. Such malleability is not necessarily a flaw, rather it is what allows our understanding to remain flexible, to integrate new information, and to adapt. It also implies, however, that even our most established understandings, rooted in memory, are themselves ongoing constructions. It is vital to recognize that these mechanisms of memory formation, pattern recognition, and reconstructive recall do not operate merely for explicit recollections of past events, like remembering what you had for breakfast. Rather, these processes underpin our entire experience and understanding of meaning. Every perception, every thought, every feeling of familiarity, every seemingly self-evident truth about the world or ourselves is a manifestation of these ongoing neural processes. The meaning we experience in any given moment, whether it's understanding a spoken word, recognizing a social cue, feeling the import of an idea, or navigating a physical space, arises from the activation of learned, consolidated, and often automatically triggered patterns within our neural architecture. These patterns are themselves the product of past learning, shaped by affect and neuromodulation, and are continuously, if subtly, being reshaped. Thus, the very fabric of our subjective reality is woven from these dynamic, memory-based neural processes. This fundamental capacity for matching present experience to learn neural representations is by no means confined to our direct sensory engagement with the external world, such as identifying a physical chair in a room or discerning a familiar face in a crowd. The same principles operate with mental stimuli. Consider, for instance, the act of recognizing the properties of a chair, even when no actual chair is physically present. This involves the activation of a rich, abstract conceptual pattern, a mental model distilled from countless past encounters, encompassing not just typical visual forms, but also its function, something to be sat on, its typical materials, the actions it affords, its relationship to other objects, and its broader cultural significance. In all instances of pattern recognition, whether the stimulus is an external object, an internal concept, an emotional hue, or a cognitive habit, the core neural process involves activating specific learned configurations of synaptic connections, the neural ensembles constituting the recognized pattern. In tracing this path, we see how initial affectively charged learning events, driven by neuromodulation, contribute to the formation and consolidation of memories. These memories, in turn, enable the recognition of patterns that apply to both our external world and our internal landscape of thoughts and concepts, giving rise to the feeling of familiarity and shaping our expectations. With repeated reinforcement, these recognized patterns can become automatic and habitual ways of understanding. Yet, crucially, this entire edifice of memory-based understanding, which constitutes the very essence of how we make sense of everything, appears not to be static, but rather dynamic and reconstructive, constantly, if subtly, evolving. The understanding we possess at any given moment, then, seems to be merely the current state of this ongoing adaptive process. Okay, so then we can consider how this ties into our broader social lives. Having explored the intricate neurobiological processes that underpin the formation of understanding, how our brains, through remarkable plasticity, the consolidation of memory, and the crucial influence of emotion-driven learning, build and refine their models of the world, our inquiry arrives at a natural and pressing juncture. We have seen how the machinery of understanding operates within the individual, adapting and learning from experience. Yet, this very machinery is not self-contained, nor are the experiences that fuel it arbitrary or uniform. This leads us to a critical set of questions. If emotion so powerfully gates neuroplasticity, what are the most consistent and impactful sources of emotionally significant experience in a human life? If memory builds patterns from recurring inputs, what are the dominant contexts shaping these repetitions? And if our understanding is dynamically constructed, how do the nature of these inputs and our capacity to process them evolve over time? The answers to these questions compel us to broaden our lens beyond the individual's internal mechanisms and to consider the rich, shaping forces of lifelong development in our deeply social existence. These are not merely passive backdrops against which understanding unfolds. They are active, formative currents that continuously provide the raw material and contextual framing for the neuroplastic and mnemonic processes we've just examined. Indeed, while many forms of experience can trigger the emotion-driven learning that leads to lasting changes in our neural architecture, it is arguably our engagement with the social world that offers the most pervasive and potent stream of such experiences. Our brains are exquisitively tuned to social cues, and our interactions with others are inherently laden with the emotional significance that drives deep learning and the adaptation of our predictive models. Furthermore, the way these social and other impactful experiences are encountered, interpreted, and integrated into our understanding is not static. Our cognitive capacities, emotional sensitivities, and even the functional organization of our brains undergo profound transformations from infancy through adulthood. To grasp how an individual's understanding takes its unique shape, we must therefore also consider this developmental arc, which dictates both our readiness for certain types of learning and the nature of the social environments we typically inhabit. Our previous exploration established the fundamental principle that emotional states are not fleeting, inconsequential experiences, but powerful sculptors of our brain's architecture. We saw how neuromodulators, released in response to affectively charged moments, critically influence the neuroplastic processes that enable learning and the reshaping of understanding. We intuitively recognize that, as inherently social creatures, our interactions with others form a dominant contributor to our emotional lives. From the profound bonds of early attachment that shape our foundational sense of security to the daily currents of peer collaboration, competition, acceptance, and rejection, our social world is uniquely saturated with the very emotional significance that tags experiences for lasting change. Indeed, much of what we come to know, from basic survival skills to complex cultural norms and abstract knowledge, is learned directly from or in concert with others. It is therefore essential, as our first step in understanding the broader impact of development and social context, to examine precisely how these pervasive social dynamics actively shape the emotional and neuromodulatory landscape that underpins nearly all significant enduring learning. How then do these social interactions systematically engage and direct the mechanisms of emotion-driven plasticity to construct our understanding? To begin, consider how readily social cues are perceived and how deeply they resonate emotionally. A smile, a frown, a shift in tone of voice, the sense of being included or excluded, these are rapidly interpreted by specialized neural systems, often triggering immediate emotional and physiological responses. The warmth of acceptance can flood us with positive affect, while the sting of rejection can feel strikingly akin to physical pain. These experiences are not just fleeting feelings, they are accompanied by shifts in our internal neurochemical milieu. The joy of collaborative success might trigger a surge of dopamine, reinforcing the behaviors that led to it. The anxiety of social evaluation could heighten norepinephrine, sharpening our attention to potential threats or vital feedback. And the comfort of a supportive presence can release oxytocin, buffering stress and fostering a sense of safety. It becomes clear then that our social environment is a constant source of the very emotional states that, as we've seen, gate neuroplasticity. Let's explore how specific facets of our social lives might steer these emotion-driven learning processes. Think back to our earliest social bonds. The quality of early attachment experiences, for instance, profoundly shapes an individual's developing stress response systems and emotional regulation capacities. A secure, responsive caregiving environment helps to establish a baseline neuromodulatory tone, perhaps involving stable serotonin levels and well-regulated cortisol release, that fosters a sense of safety. This emotional foundation doesn't just feel good, it creates a neurochemical landscape for exploration, curiosity, and the robust encoding of new experiences. Conversely, early environments characterized by unpredictability or threat can sensitize stress pathways, potentially biasing learning towards threat detection and making it harder to engage openly with new information. As we navigate our broader social worlds, the dynamics of acceptance and rejection continue to act as powerful learning signals. When we are recognized or praised, the associated positive emotional states, often fueled by dopamine and endogenous opioids, effectively tag the contributing behaviors, knowledge, or social contexts as valuable and worth reinforcing. We learn what gains approval, what fosters connection, But what happens when we face social disapproval or exclusion? Such experiences can be intensely aversive, triggering the release of stress neuromodulators like norepinephrine and cortisol. While these can, in some instances, focus attention and facilitate learning to avoid similar future pain, chronic social stress or severe ostracism can also impair cognitive functions and disrupt healthy plasticity, sometimes leading to withdrawal or the fragmented encoding of these difficult experiences. Our learning is also profoundly shaped by observing others, a cornerstone of social learning. We don't always need to experience consequences directly. When we witness someone else being rewarded for a particular skill or behavior, or perhaps being met with disapproval, our brains often activate remarkably similar neural pathways, including those involving emotional resonance and neuromodulatory responses. This vicarious experience, feeling a shadow of their joy or discomfort, can effectively tag the observed information for our own learning. Acetylcholine might play a role here, sharpening our focus on the actions and outcomes deemed salient through observation, especially when learning from a mentor or trusted figure. In this way, social observation allows for the efficient transmission of cultural norms, skills, and crucial safety information, all colored and weighted by the perceived emotional outcomes for others. Furthermore, the presence of supportive social relationships can act as a significant buffer against the detrimental effects of stress on learning. Knowing we have others to turn to who offer empathy and encouragement can modulate our physiological stress responses. This social buffering effect, potentially mediated by oxytocin and a downregulation of the amygdala's reactivity, can create a more resilient neurochemical environment. In such a context, we may be more capable of facing challenges, taking intellectual risks, and consolidating learning, even in the face of difficulty, because the background emotional tone is one of security rather than high alert. Even the complex dynamics of cooperation and competition within groups are rich fields for emotion-driven learning. Successful collaboration towards a shared goal can be intrinsically rewarding, likely involving dopaminergic reinforcement for both the process and the outcome. Navigating competitive landscapes, on the other hand, can heighten vigilance and arousal via norepinephrine, intensely focusing attention on relevant cues and strategies. The emotional stakes in these situations, the pride of success, the disappointment of failure, the sense of fairness or injustice, all contribute to how deeply and what aspects of these experiences are encoded into our understanding of social structures and our place within them. Over time, these recurring socially mediated emotional experiences and their neuromodulatory consequences compound. They don't just lead to the acquisition of isolated facts or skills, they cumulatively sculpt our broader understanding, our models of the world. Consistent experiences of trust and collaboration will likely foster a different predictive model of social interactions than a history of betrayal or intense, unresolved conflict. These emergent understandings, in turn, guide our future perceptions, interpretations, and emotional responses in social contexts, creating recursive cycles that can either reinforce adaptive patterns or, in some cases, entrench maladaptive ones. Therefore, what emerges is a picture of learning that is far from a solitary cognitive endeavor. It is deeply and continuously interwoven with our social existence. The way we connect with, learn from, and navigate our relationships with others is not merely a backdrop for learning. It is a fundamental driver of the emotional neurodynamics that govern how our brains change and how our understanding of the world is constructed. Our social lives breathe life into the emotional mechanisms that, as we've seen, are the gatekeepers of enduring change. So let's consider these social influences across the lifespan. The profound impact of social dynamics on our neural architecture, as we've just explored, provides a crucial lens through which to examine the entire arc of human development. Having seen how deeply social interactions engage the emotion-driven neuroplastic mechanisms that sculpt our brains and enable learning, we now turn to consider how these powerful forces are a continuous and essential current running through each phase of life. Each developmental stage presents unique environments that become the primary crucible for learning, internalizing, and refining the understanding that guides our perception and behavior. This socially embedded development of understanding begins in infancy, where the relationship with primary caregivers forms the paramount social context. The infant's exceptionally plastic brain forms its earliest and most foundational models about the world's predictability, safety, and responsiveness primarily through these interactions. In these caring exchanges, an infant learns fundamental causal relationships by observing how their actions elicit responses from others, thereby influencing their surroundings. Communication, acquired entirely through countless social exchanges, provides the bedrock of complex human understanding as infants learn to associate sounds with meanings and intentions via the guidance and feedback of others. Even early play, predominantly social, allows children to experiment with roles, begin to grasp others' perspectives, and test hypotheses about how people and objects behave, laying the initial architecture for a broad, interactive understanding of their world. As children transition into middle childhood, their social sphere expands dramatically. The school environment and burgeoning peer relationships become central arenas where understanding is socially constructed. It is largely through direct social interaction, negotiating with peers, collaborating on tasks, and navigating shared rules, that children develop a more sophisticated grasp not only of social dynamics like fairness and cooperation, but also of logical principles and problem-solving strategies which they then apply to many domains. Their cognitive development is constantly applied to and refined by challenges encountered in these social settings, from interpreting a historical narrative as explained by a teacher to deciphering game rules with friends. Formal education, a structured social enterprise, explicitly transmits vast amounts of cultural knowledge about science, mathematics, history, and the arts, all mediated through social pedagogical methods. Teachers, as significant social figures, model ways of thinking and provide feedback that shapes a child's confidence in their ability to understand complex subjects. These experiences collectively build an increasingly nuanced understanding of causal relationships, systemic processes, and the vast body of knowledge accumulated by their culture, all learned and validated through emotionally resonant social interactions. Adolescence then ushers in a period of profound social reorientation and cognitive advancement, where the development of a more abstract and multifaceted understanding becomes intensely intertwined with the social pursuits for identity and belonging. The brain's ongoing maturation facilitates abstract thought, which adolescents apply to philosophical questions, scientific concepts, and ethical dilemmas concerning the broader world. Peer groups thus become critical forums for debating ideas, challenging established norms, and co-constructing new interpretations of reality. Identity formation is predominantly a social project involving understanding oneself in relation to social categories, cultural narratives, and feedback from others regarding potential future pathways. The intense social emotional experiences of this era, acceptance, rejection, navigating complex social dynamics, powerfully sculpt not just self-perception and social acumen, but also the foundational conceptual models and ideologies through which adolescents interpret and engage with the world at large. The journey continues into emerging adulthood, a stage characterized by applying and testing established understanding within new and diverse social contexts. Higher education and entry into the workforce immerse individuals in rich social learning environments where knowledge and skills are further honed. Abstract reasoning, cultivated in earlier social and educational settings, is now actively applied to practical, real-world problems, often through collaborative efforts in professional or civic spheres. Mentorship, a key social learning mechanism, profoundly shapes understanding within specialized domains, as experienced individuals transmit not just explicit information, but also the implicit operational logic and values of their fields through interaction. The understanding of self further integrates with a growing comprehension of societal structures, largely through experiencing one's roles and contributions within various social systems, leading to a more mature and pragmatically grounded worldview. Through the entirety of adulthood, this socially driven evolution of understanding continues. Ongoing engagement in diverse and evolving personal, professional, and community relationships consistently provides new experiences, perspectives, and challenges that necessitate the refinement of what we know about the world and ourselves. Through dialogue, collaboration, shared endeavors, navigating conflicts, and observing the outcomes of others' actions within these varied social arenas, we are continually learning, from practical short-term adaptations about minute social norms or facts about the world, to profound reevaluations and transformations of our more fundamental belief systems and our core sense of self. The emotional resonance of these continued interpersonal experiences ensures that our capacity for neuroplastic change remains engaged, allowing our understanding to remain dynamic rather than static, continuously shaped and reshaped by our connections with others and the collective human experience. So let's consider what this means for our shared understanding and norms. Our exploration so far has detailed how individual understanding is forged through emotion-driven neuroplasticity and unfolds within direct social interactions across developmental stages. Now, we turn to how these very processes of individual learning and social engagement culminate in the broader shared understandings and norms that constitute what we call culture or society. This is not a one-way street where a pre-existing society imprints itself upon individuals. Rather, it is a dynamic, reciprocal process. The countless emotionally resonant interactions between individuals progressively build and sustain a shared social reality, which then, in turn, shapes the ongoing development of understanding for everyone within that context. At its core, much of our earliest learning is an attunement to social norms, guided by the conditioning inherent in our interactions. As infants and young children, our responses to stimuli are continuously shaped by the reactions of parents and significant caregivers. When our expressions of understanding or our behaviors align with what is deemed correct or appropriate within our immediate social environment, we often receive positive emotional feedback, attention, approval, comfort, which, as we've seen, reinforces those neural pathways. Conversely, when our actions or interpretations deviate significantly, we might encounter corrective feedback, whether through gentle redirection, expressions of concern, or the withholding of positive engagement. This social conditioning is fundamental. It's how we begin to internalize the baseline expectations and shared ways of making sense of the world that are prevalent in our families and immediate communities. What we learn is not just isolated facts, but normative ways of perceiving, interpreting, and responding. As our cognitive abilities mature and our social worlds expand, especially through childhood and adolescence, we increasingly encounter situations where what is right or what is true becomes more ambiguous. In these moments, the process of understanding often involves a form of ongoing implicit negotiation with others. Through discussions, observing the consequences of others' actions, gauging emotional responses in complex social situations, asserting our own perspectives, and adapting based on the feedback we receive, we collectively, if often unconsciously, shape and reshape shared meanings. Social dynamics, including hierarchies, peer influence, and the emotional weight of acceptance or exclusion, play a significant role in these negotiations. An individual's understanding, impacted by these emotionally charged encounters, influences their subsequent interactions, contributing to a continuously evolving consensus or sometimes conflict about how things are to be understood. This ongoing cycle, where individual learning is socially conditioned and ambiguous understandings are interactively negotiated, is what, in aggregate, gives rise to the broader patterns of shared beliefs, values, behavioral expectations, and common knowledge that we recognize as cultural and societal norms. These are not monolithic entities handed down from on high, but are emergent properties, the relatively stabilized outcomes of countless individual interactions, emotional exchanges, and shared experiences over time. Language itself, a primary vehicle for this shared understanding, is a living testament to this process, constantly evolving as new terms are coined, meanings shift, and communication conventions are collectively established and adapted through use. Crucially, while each individual develops a unique understanding based on their specific history of interactions, this relentless process of social conditioning and negotiation ensures that we arrive at pragmatically similar understandings with those around us. Our habitual responses to common stimuli, our interpretations of shared symbols, and our expectations in social situations become aligned enough to allow for effective communication, collaboration, and relatively smooth social functioning. This pragmatic similarity is vital. It enables us to navigate our social worlds with a degree of predictability, minimizing the constant arousal of negative emotions that would arise from pervasive misunderstanding or conflicting expectations. We learn to operate within a shared framework that, while never perfectly congruent between individuals, is sufficiently overlapping for societal life. And here the reciprocal loop becomes fully apparent. Once these shared understandings and norms emerge and achieve a degree of stability, They form the dominant social context that profoundly shapes the learning and development of new members of the group, such as children, and continues to guide the interactions of all individuals. The culture that arises from past interactions becomes the implicit curriculum for future learning. The emotional responses and social dynamics we've discussed are then experienced within this co-created normative framework, reinforcing it or at times providing the impetus for its gradual change as new generations and new experiences lead to fresh negotiations of meaning. Therefore, our understanding of the world is not merely influenced by social context as an external factor, it is inextricably and constitutively linked to it. Individual minds, through their interactions, build the social world, its norms, its shared meanings, its culture. Simultaneously, this socially constructed world provides the essential framework, the tools, and the feedback mechanisms that shape each individual's developing comprehension of reality. It is a continuous dance of mutual creation, where what we understand makes our social world, and our social world makes what we understand. So we can end off with considering the shape of our understanding. Throughout our broader inquiry, understanding has emerged as a pivotal element, a primary capacity through which we interpret, engage with, and derive meaning from the world, thereby profoundly shaping our experience. We delved into its neurobiological underpinnings, witnessing how emotion-driven plasticity sculpts our neural pathways. We traced its developmental arc as it evolves through socially embedded experiences, and we examined how even our broadest societal norms and cultural frameworks arise from and feed back into a dynamic interplay of individual interactions and shared meanings. This multifaceted investigation has revealed our understanding not as a static acquisition of facts, but as a deeply embodied, constantly evolving, and co-created phenomenon. Having established this rich perspective on how understanding comes to be, a natural and pressing question arises. How can we conceptualize the nature and structure of the understanding that results from these complex formative processes? As individuals, we experience our own understanding, our knowledge, beliefs, and expectations as a somewhat coherent, if ever adapting, guide to navigating our world. How does this phenomenological sense of knowing relate to the underlying neural complexity and the vast web of developmental and social influences we have discussed? To truly engage with the understanding we possess, to explore its nuances, its potential for change, and its role in our pursuit of meaning and freedom, we require a framework that allows us to think about its structure and its dynamics. This need to model and interpret our understanding now demands our full attention and will shape the focus of the next major section and our next read-through video. Okay, so unpacking this section. The main points we have: experience is always already conditioned by what came before. We use the word predisposition to represent this idea that we are predisposed to experience the world in every moment. This predisposition is not a fixed trait like a disposition, but a dynamic moment-to-moment orientation. We discussed the biology of this changing predisposition, specifically in relation to our understanding. We looked at neuroplasticity, the physical basis for learning and adaptation. We considered how important emotions are in this process. Emotion and neuromodulation determine what sticks. We learn what feels significant. Then we considered how important social dynamics are in this process. Our predictive models are largely co-created through social interaction. Norms and shared meanings shape our individual neural architecture. This gives us our first semblance of what we might mean by freedom. If understanding is malleable and accessible through reflection, perhaps we can do something to influence it. So in the next video, we are going to read the major section, Conceptualizing Our Understanding, which leads us into the more philosophical discussion of how we can conceptualize our understanding in ways that make sense of what we just discussed today, as well as providing us a practical tool for deliberately engaging with the world. So to help us make sense of how we can deliberately act, as well as influence our understanding, we can consider how to make sense of the contents of our understanding. What things arise in our experience of meaning? How do they relate to each other? That is the necessary step that will lead us to being able to talk about some sort of freedom. So thank you for watching. I hope you enjoyed, and see you for the next read through. Have a good rest of the day.